Okay, so just a broad overview of t-test. Most of the questions I've gotten all eventually stem back to t-test or concepts within them. So let's take a rather broad look at what these t-tests do and essentially what the purpose of a lot of these inferential statistical tests are. So again, just a visualization of it. So let's say that we have school A, and this is the distribution of school A's grades. Again, just a normal distribution like you've been seeing. Let's say that the average grade for school A is 75. So you see, it's right there in the middle of that distribution. So let's take another school, school B's average. This is their distribution, and if you look at their distribution of grades, the average for school B is 80. So let's line those up together. Let's take school A and school B. So again, that light blue one more on the left is school A with its average of 75, and the grayer one on the right is school B. So what we want to know is, are the grades different between the schools? Well, we saw that the mean, the middle of those distributions, they look different. School B students had an average grade of 80, but if you look at the overlay of these two distributions, however, it's hard to tell. Mainly look at all the overlap. Look at all the overlap. If I were to just randomly point at a spot on these distributions, let's say just right here, if I pick a spot randomly, how do I know whether I'm touching school A's distribution or school B's? So there's way too much overlap here to be confident that I'm touching one school and not the other. There's no way to tell which one I'm touching. So there's a lot of overlap. Well, what about now? Okay, now are they different? If the means and distributions were this far apart, well, we see there's still a lot of overlap. In fact, if you continue just to look at the lines there, where those means for each distribution are, just looking at the mean of either school, it's going to fall into that overlap area. So again, if I just touch one of these schools at random, how do I know whether I'm touching school A or school B? How do I know which one I'm touching? If I just choose something randomly, there's still too much overlap. Okay, what about now? So the overlap here is a lot smaller, and the means of each school, the middle of those distributions, they no longer touch that overlap area. Again, this is just a visual representation of what's going on when we do a t-test. Or a lot of the tests we're going to do are going to come back to this general idea. So we're using a statistical test, such as one of these t-tests, to tell us if these two groups, these two distributions, are different enough that we only have a small chance of mistakenly touching one school or the other. So if I pick a point at random over here, I'm pretty confident I'm touching school B. Over here, I can be pretty confident I'm touching school A. There's not nearly as much overlap. So one way to picture it is that if they're this far apart, and again, this is a visual representation, is that we only want a 5% chance of being wrong here. Or in other words, we only want 5% overlap of these distributions. So going back to your lecture, that's where the whole idea of alpha equals 0.05 comes from. We want to know, are these distributions far enough apart that there's only that small bit of overlap? And if there is, it gets to that point, we say that they're now statistically significantly different from one another. So this visual representation here, this is what a t-test quantifies. Are they far enough apart that the overlap is so small that there's only a 5% chance that I'm touching basically the wrong distribution?